All right, so it's week 8. We may as well get started. I'm going to do a couple things today. Haven't done your little GitHub lab 4, make sure you do that. It won't take you long. Okay, easy, few marks. So you want to make sure that you get that submitted. So we're going to do a couple of... Yeah, all I need is the link to the repository. You have to invite me. So when you make a private repository, you're the only person that can see it. So here is how you invite me. Right.
I sent you the link, you'll never get
right. So what happens if you give me the link and I click on it, but it's private and you haven't invited me, GitHub gives me a 404 error is what happens. So here's how you do it. Actually, I guess I better take a private repository. Once you've created your repository and you've put it online, if you go into the repository settings right here and click on collaborators, it may prompt you for your password. So you can just search by usernames. You can type in my GitHub username, which is on Blackboard, which is IFOTN. It's in front of the net. So if I type, Brandon, what's your GitHub username? That's you. It's also helpful to have an avatar. So if I choose Brandon and Adam as a collaborator, GitHub will send Brandon an invitation email, and you just click on it, then you have access to it. So for basically everything you submit for me, basically from now until the time you graduate, that's how you're going to submit it. Rather than putting your code on Blackboard, you'll create a private GitHub repository, so your code's backed up online, and then you just send me an invitation. So with every one of my classes, whenever I have an assignment due, I get like 30 emails from GitHub saying, you know, each student's inviting you, and I have to go and click and accept all those invites. So you can find my GitHub right here. So in weekly learning and tools and resources, the second item is Rich's GitHub page. So obviously my username's on the end of that URL. Okay. That's also where I'm going to put any files, like all the work we do in class, rather than uploading it to Blackboard every week, I'm just going to put it on GitHub at the end of class, and it's public. Log into Blackboard to get any work that we do. I will just make a new repository every week. So you can see here's all the students that are inviting me to their assignments. So here was last week's lesson. In class, like this, our course code, which lesson it was, and a description of what we did in that lesson. So today I'll do the same. We'll upload our code to GitHub. I may actually have 2 separate repositories today. We'll see. So if you miss class or you're working on something you didn't get it working, my version will always be on GitHub. I usually, right at the end of class before I leave, I push it up so it's there. So I remember to do it. So I realize GitHub is new for most of you. It's going to get very familiar very quickly. Okay. So we want to deal with a couple of things today. We're going to spend the first part of class, it's not going to take the whole class, we don't really need a whole lesson on it. We're going to talk about input validation. So we've talked a lot, we've built applications where we get input from users. We haven't really done anything in terms of checking whether we got the kinds of information from our users that we want. It's not really a 3-hour lesson. It's probably something we can cover in the first part of the class. So what we'll do, the first thing we'll do is we'll take what we did last week in week 7. And again, if you weren't here or you didn't finish it, well, you can grab my solution off of GitHub and download it. Grab my lesson 7. So all you do, there's always a download button. So you can just download the whole thing as a zip file, open it up, save it on your computer, and then you have a copy. So we'll work with that. We'll kind of do that one together. And then what we're going to do is you guys are going to add input validation to your assignment 1. Assignment 1, while there's a copy of it on Blackboard that you can use. That's going to be the first part of class. The second thing we're going to talk about, which is probably going to run into next week's lesson, which is fine, are arrays. So an array is basically just a list of variables that are related somehow. We've worked with individual variables, but many times we've got relations between them. So that's probably going to take us into next week, which is fine. Okay. Just a quick reminder, I think Tuesday is the last day to withdraw without academic penalty. That was original. I'm pretty sure it was the 5th. I think it was November 8th, but they changed. It's normally much earlier, but due to the strike, they moved it back. Maybe if I'm giving you this information, it might be good if I'm actually sure I'm right. So let's just double check that. Okay, looking around the room, I mean, it is your money and your education. Looking around the room, most of you are here every week. People are doing fairly well. So I would hope most people are comfortable that they can continue on in the class and move on to next semester. But let's just see. We'll check that date. Yes. So it's been moved back. Well, that's your last day to withdraw and get a refund due to the strike. Although I think that's for the entire program. Yeah, I think so the last way to withdraw without academic penalty is not until the 15th. So you still have some time. Oh, that date, sorry. We'll talk about assignment 2 a bit later, so that'll be due just before Christmas. And then obviously that Friday in January is our final exam. So we sort of talked right from week 1 that all programs really do is collect inputs, do some processing, and display output. And every application you've ever used of any kind, doesn't matter what the device is, what the purpose of it is, it's all just some combination of that. So we've built a whole bunch of programs to take inputs. But one issue that we have is we need to make sure the inputs we get are good. And this is even more important than ever when we're building stuff on the web, because most of what we put on the web, or if we build mobile applications, it's public, right? We can't control who's using that. It's not necessarily people we're training on how to use that stuff. So we need to make sure when we're asking people for information, they give us information that's useful. So if we think about building web applications, what are some of the inputs we might ask users to give us that we want to check before we can actually process those? Okay, so we'll maybe make a quick list here. Right. Now, we can't actually check, we can only check certain things about email. We can really check the format of an email, right? That the input somebody gives us looks like an email address. Whether that email actually exists or not isn't something we know, right? We won't know until we actually try to send a message. But this is really important in web applications. If we have an email box that we can validate that at least what they're giving us looks like an email address. Why is this so important? Why do we care if somebody puts in text in an email box that isn't really an email address? Stuart? Right, okay, so if somebody enters this as their email, what's going to happen in our program when we try and send them an email message? Yeah, it's going to generate an error, right? Because a mail server is going to throw an error and our application is going to crash. Okay, so there's a good chance that person's going to wind up seeing an error message at some point. So email formats are really important. What other kinds of things would we ask users for that we want to check? Okay. Sure. Yep, they're not going to type ABC into a credit card field. What else? What other kinds of things, information are people going to give us that we need to make sure we're checking? Okay. Yep. Can't get in here unless you're 18. Right? Now, obviously, someone who's 9 can click, yes, I'm 18, or they can type 18. Nobody does that, right? But this is partly a cover your butt thing as a web developer, right? If we give access to people who shouldn't have access, we can be held responsible. So we at least need to build the page with the age check. And if, well, the user lies, but at least we've done we've met our responsibility. What other kinds of things would we want to check? Let's say we had a sign up page on our web form, on our web page. Yeah. Okay. Now we'd probably want to check several things about a password. What kinds of things, when we ask someone for a password, do we want to check? Brandon? Okay, so yeah, we might want to do a comparison, right? Usually if we have got passwords, we're going to give them when they're signing up 2 fields, and we want to make sure first password equals the second password. What other things would we check? Joel? Yeah, we don't want a password like this. We might make sure it's got a certain number of characters. What else would you want to check on a password? Yeah, we could enforce strong password rules. So the world's most popular password, which is this, right? We probably don't want to allow that. We want to enforce maybe things like uppercase, lowercase, numeric characters, special characters in a password. Okay, what else would we on a sign up form? What other kinds of checks would we do? Absolutely. So any field that the site we're building, any field that it needs, we need to validate and make sure the user hasn't left it empty, right? So that's probably the most common validation, is just that we got a value. Oh.
This is easy to check. There's no 90 Owen drive, so you'll be able to check that I meant to type 9 Owen drive.
Yep, something was harder to do a long time ago, but much easier to do now. Yeah. When we're asking for addresses, we can probably check that those are real addresses. Anything else we might want to check on, let's say, a sign-up page? Okay. Well, date formats are important, right? If we're going to ask people for dates, they need to look like dates. We can't have somebody type ABC in a date field, for example. That's going to crash when we try and save that information. Anything else? Any other rules you can think of or things we might want to try to check? Yeah. Absolutely. Imagine the disaster that would cause if you went to an application and it let you sign up with any username you wanted and it never bothered to check. Good luck logging in. Hope your information's secure. Right? They don't check that. Mike? Yeah, absolutely. That's a type of validation, right? And we'll actually do that next semester. We'll learn how to integrate. What's the most common way that websites do that, Mike? What?
Those stupid sign things that you click on once a car was.
Yeah, what are those called? Yeah, it's called ReCAPTCHA. Actually, we can have a quick look at that for a second. So ReCAPTCHA is actually kind of interesting for a couple of reasons. It was originally, you notice originally with ReCAPTCHA, several years ago, you didn't get the street signs. What did you get instead?
I got a little image. I feel like the letters, numbers were.
Yeah, so what you saw in this on the second slider, where that actually came from is Google decided, actually, it wasn't Google that decided, it was at University in Pittsburgh at Carnegie Mellon. Some professors they started a process of digitizing old texts. They wanted to make a digital library of all these old manuscripts and texts. So what they did, they would scan the old text, but many times they looked like this and they were hard to read. So the actual CAPTCHA codes that you got presented with came from old books. So what would happen is, a million times a day, people would get a word in an old book. And if enough people entered the code the same way, then they figured out, okay, this is what that word must be when the characters aren't scanned clearly. So it was actually doing millions and millions of human hours of work. And then, of course, Google swooped in and bought the thing. So ReCAPTCHA is now owned by Google. Now, we don't see these anymore. We see the street signs instead. What's Google using that for? The images we get today in ReCAPTCHA. Yeah, Google Maps and Google Earth. Right? When you see house numbers, it's because Google's car drove down somebody's street and didn't get a very good picture of somebody's address and house number. So they're showing us that on ReCAPTCHA so we can confirm that proper address. So we'll actually look at, and this is a free library, we'll look at this next semester when we build a registration and sign up form with HTML and PHP. We're going to want to include ReCAPTCHA. It's a free library. So we're going to look at how do we integrate this. Because whenever we're building a form on a web application, we probably need this now. It's pretty standard. Okay. So that's for sure an important one, because you'd be amazed at the crap you get on your forms on the web if you don't have some kind of anti-bot, anti-spam checker. You think of anything else on a sign-up form? Or any other kind of input we might ask for a user on a web application that we would want to validate?
Backup questions, so if you forget your password.
Okay. Yeah, so we have forgetting password. Nope, not exactly the same, but related.
Security question.
Okay. And one of the other common ones is just wherever we're asking for a number, we need to make sure the user gives us a number. Because probably there's a good chance at some point we're going to do math using that value. Right? Imagine if a shopping cart let you type ABC in the quantity box beside the product you wanted. Well, what's going to happen when it tries to calculate the value of your shopping cart? It's going to bomb. So any place we're asking for numbers, we need to make sure that we actually get numbers. And also that those numbers are within an acceptable range. For a quantity, or if Blackboard asks me to enter a grade for one of your assignments, it's not going to allow me to enter minus 50. Although there's times where I've wanted to enter that, not often, I can't do it, right? Blackboard says, no, your grade's got to be between this and this.
Would only entering like one password, one email address be part of it? Like, I guess it wouldn't be. You would only enter one email address.
Yeah, but part of the validation would be where we have two password fields that we're making sure that they're equal. Right? That would be an example of where we're doing input validation. So before we get to the processing phase, we're checking, did the user give us did they give us all the values we need? And B, did they give us all the values in a form we can use it, that it meets all of our rules and our requirements? So it's not a very difficult job. but it's something we need to do whenever we're asking users for input, because you would be amazed at what people will enter into our applications if we allow them to.
The last thing that most of these signups ask for is, have you read the terms and
Yeah, so often we just have a simple checkbox, right? You need to approve this, or this counts as your signature or authorization online, right? We can't necessarily get a digital signature, but checking this counts as your signature. So we're not going to enable that register button until you check that box. So it's not really complicated, but part of our responsibility is we have to figure out if these are the things that the application needs, this is the information, what rules make sense? And we don't always get it right. For example, I built a web application a few years ago where we had a field for postal code. And there were customers in Canada and customers in the US. So we allowed, I allowed 7 characters maximum for a postal code. So that's one of the other things, is we might check the input size, right? We don't want more than 7 characters for a postal code. So somebody could enter this, space. And that seemed to work great for a while. And then I got a call from, or actually an email from somebody saying, I'm trying to sign up and they live, it keeps telling me my zip code is invalid. They were in Alaska and their zip code was like this. These are valid postal codes but valid zip codes in the USA. Most people don't have these 10-digit zip codes, and I never thought somebody would try to sign up for this application, and every time they hit the sign up button, it gave them a red error and said, no, this isn't valid. So we actually had to change the rules from 7 characters to allow 10 characters. So we do our best to try and make up rules that make sense. Always get it right. So these are often questions when we're building an application. These are questions we want to ask either our project manager or our customer. You know, you want a registration page with all of these fields. Which of these fields are required and which ones are optional? Because we're going to have to make sure that we're enforcing the user to enter values and get the right values. So this is often a question about our customer. You know, if we're building a site where our customer can enter products, well, what's the highest price we should allow? At what point do we show an error message and say, no, that price can't be right? But part of this is a conversation with whoever we're building the application for about what they need in terms of building these rules. So what we'll do, I'm going to open up what we did last week. Actually, I already have it open. So if you have this little solution from last week, you can open it up, your week 7 solution. You can grab it off of GitHub. Get it off of GitHub, you just go into Blackboard, go into the weekly learning and tools and resources, and open up my GitHub page. Which will take you here. And if you click this repositories link kind of near the center of the page, should be the 4th one is our lesson files from last week. But if you don't have it, so if you click on my repository, you can just download the zip file and open it up, and then you can open the solution in Visual Studio. So I'll give you a minute if anybody needs to go and grab that one. So we're going to try adding some basic input validation to our little project. We don't have any here. We didn't ask for any inputs on here, but here we had 2 inputs. So when I ran this, is how we built it last week. However, we didn't do any input validation. What's going to happen if I just click my add button here is we get this. So our text in our X box is an empty string. So when we try to convert that into an integer, so now we've stopped our program. Or if I run it again, and I don't leave them blank, but I put in values that aren't numeric, we get the same thing happening. So if we're going to expect the user to give us a number here, before we try to convert that value, or as we try to convert it, we also need to be checking that in fact it is a number. And if it's not, we need to give some indicator to the user telling them what it is we need. So I'm going to kind of change our comment here. We'll capture X and Y. So this is going to just convert the value of that box every time, whether we have a number or not. Now the C# language has lots of other methods we can use for checking values. So the one we want to use is called Tryparse. Here's from the documents. So it tries to convert a string to a number, but it gives us a value back that tells us whether we are able to successfully convert to a number or not. So if it's successful, we get a true value. If it's unsuccessful, we get a false value. So we're going to want to use this Tryparse method to determine, well, did we actually get a number here and here? So I'm going to comment these values out. Sorry, comment out those lines. And we need to use an if statement because we have a decision to make. We need to check, are we able to successfully get a number or not? So we're going to call the Tryparse method. So we're calling this method, it's built into the C# library, and this method asks for two pieces of information, two parameters. The first one is, what is the value we're going to try to convert into an integer? In this case, it will be our, whatever value the user typed in our X text box. Try to convert it. And then here, it's saying out integer result. So what this means is, if this is successful, what variable name is coming out? Are we storing this in? Actually, wait, we're going to do this. We actually want to check if it's false. So if this fails, if we get back a false, it means the user didn't give us a number. We can't convert whatever they typed into a number. So in this case, we want to print out an error message. We've already got a label here. So we could say LBL sum dot text equals their number x. So now we want to do the same thing with y. So let's try this and see what happens now if we enter values that aren't numbers. So we're going to try to convert x to a number, and if it doesn't work, we'll display an error, and then we'll do the same thing with y. We're going to have to do a little more here, but we can see where we get so far. So if I put invalid numbers, still works. Okay. I thought I would crash it. I'm going to try that again, just a second. If I leave them blank, actually, we'll try it this way. So I typed in A, but it just treats my x as 0. It's interesting. That is not the result I expected. We're going to have to change this a bit. So if we don't enter numbers, if I enter A and B, it just treats them as zeros. It actually isn't the result we want. In this case, we need to tell the user okay. Bear with me for a sec. We have to try a different way. We'll try this. Okay. We'll just try this for a minute. We'll just try it this way for 1 second. See if this behaves any differently. Nope. Okay, we'll try this. So first we'll check that X is not empty. We'll see if this works. It should. We're still adding our numbers, even though we don't put them in. I have to think for a minute. Sorry, folks.
I think it's because it's wrong stress the program anyway.
Sorry?
It calls the add function. Even though it's false, it's still going to be closed, so that's why it's trying something.
Well, that may be the issue. Let's see. We can create a variable called OK. If either of these things happen, play with it for a minute. Then we can just say if OK is true. But we're still getting 0, which doesn't totally solve our problem, because these are still coming out to 0, which are valid numbers, even when the user didn't give us a valid number. Just, I think you might be on the right track. Oh, okay. Oh, this could say. All right, we're getting there. All right, yes, I missed that part. So there was nothing wrong with what we did. So whenever we've got a whole form, and most of the time on the web, we're going to have a whole form with a bunch of inputs and a button at the bottom that the user is going to submit. So what we want to know is ultimately, if there are any errors at all, we don't want the user to be able to submit the form and process. We want to show them any error messages. So if X is not a number, we're going to print this message, and we're going to change our OK value from true to false. Our form's no longer OK, so don't do any processing. Don't run our calculation. We should maybe put a space in here. So if X is not a number, we'll tell the user they didn't give us a number. Then we're going to check Y separately, because maybe they gave us a number for X, but not for Y. So we need to check each field individually, error message individually. And here I've used plus equals in the event that both X and Y are invalid. Well, that was painful. So we'll start by saying assume the form is complete. And then we're going to check if the X input is numeric and check if the Y input is numeric. So we're starting off with our OK as true, and if we have any errors, we change it to false. And then down here, we're evaluating, did we encounter any errors along the way, yes or no? If we encountered no errors, it means the user gave us valid inputs and we can add the numbers. There's no else here because if OK is false, we've already printed the error messages up above. So we've already told the user what's wrong. Just going to run it one more time. Okay, so it works with valid numbers. But if I put in anything that isn't numeric, our validation works. So we're checking each input individually, as well as we're checking the overall set of inputs with the simple true or false. True meaning everything's good, and false meaning we had one or more problems. So we use this if we're checking numbers. Tryparse will tell us whether that input is numeric or whether it isn't. Now, maybe that's one kind of check we want. We want to make sure we get numbers. What about if we wanted to make sure that we got numbers that were not negative as well? It wasn't enough that they gave us numbers, but those numbers also have to be 0 or higher. Where could we do that? Cool. Oh. Yep, so this check runs first, and if it's not a number, we tell the user it's not a number. So if this condition doesn't happen, it means they did give us a number. So what would this look like?
Would it be?
Yeah, well, now we've got X, right? So it's been converted to a variable here. So else if
X is less than 0.
Yep. Right. So anytime we have an error, We've got to think about all the different ways users might give us the wrong stuff. So first we want to make sure they gave us a number. And then once we know it's the number is 0 or higher. We'll do the exact same thing for y. Y is less than 0. Again, so we're doing 2 checks on each input. Now, fortunately, when we're building web applications with HTML5, HTML5 has lots of built-in validators when we build forms. Have you guys built any forms in Scott's class yet? HTML5? What are some of the HTML5 validators that you could put on your inputs that will do some of these checks for you if it's a web page? Yep, there's a required attribute. Max length. Yep, you can set max length. Yeah, you've got an email, you've got type equals email, type equals phone. So HTML5, it'll do some of these checks for you. So we don't have to write this code necessarily in the back end, which is good. So I'll just check this and make sure if I enter 2 negative numbers that I'm stopped. So these are valid numbers, but they're less than 0. Here's one little problem. Why is this happening every time I click the button? Yeah, so every time the button's clicked, we should probably clear out the message on the label. And then our processing is going to run, and we're either going to show error messages or we'll show the result of our calculation. So right here at the top, as soon as the user clicks the add button, here's the message label. Whatever was on there from the last time it was clicked, let's clear it and then regenerate whatever our message will be. So that should be the first thing that happens as soon as they click the button before we do anything else. So now if I enter -200. So also, one of the other things you notice is our error messages are specific. It's not enough to just tell a user, look, your form is invalid. That's not helpful. They need to know what exactly did they do wrong and how do I fix it? What information were you looking for that I didn't provide? We don't want them to have to guess. Every time we clear out the message and we check each field individual and we show them each individual error message as descriptively as we can. Right? This is a better error message than saying, you know, invalid X value, because the user doesn't know what values are we going to allow. We're telling them it's got to be, can't be negative. Anybody have any questions so far? Still getting zeros? Okay, do you have this check at the bottom? You probably are missing that if. So Stuart, with Jaden, without that, the reason it runs is because without it, it calls add numbers anyway, right? So we only want to try to add them together when we know we have acceptable values. If the user's given us garbage, we don't want to bother trying to run the math calculation. There's an old saying in programming, GIGO, which stands, anybody heard this before, know what that stands for?
Get in, get out.
You're close. The in and the out are right. The G's for something else. Andy? Garbage in, garbage out. Right? If we don't check that we get good inputs, we're not going to be able to process things properly and generate the right kind of output. So as a developer, when we're building user interfaces, you're kind of playing defense. Right? You're thinking about what are all the things people might do to try and give me crappy information? And then what tools do I have to try and check and make sure that I'm forcing them to give me what I want and what I need? Okay, I'm going to leave this sample up. Here's what I want you to do next. I want you to take your assignment 1 that we did way back when, your little grade calculator. If you didn't do assignment 1, there is a version of it on Blackboard you can download. That's here under the assignments tab. There's a little solution file. You can download it. But if you have your own assignment 1, you can work with it. Oops, I didn't want that. So let's open up assignment 1. So this was our grade calculator where we asked the user to give us 6 grades, and then we calculated the letter grade and the average. And it ran something like this. This is the version that I put on Blackboard. If you have your own, you can use your own. You did assignment 1, so you have yours. Under assignments, right down at the bottom, assignment 1 solution. I think you got bonus marks. Yours is probably better than mine. Right? So if I enter a bunch of grades, right, this is how it worked. We entered the grades and we calculated the average, and then we used an if statement to assign each letter grade. So it was just input, processing, and output. One thing I didn't ask you to do because we hadn't talked about it was there's no input validation here. So I can do this. Well, that crashes. As soon as I take out any value and click my button, RAM. Or I do this. I also do this. Now, this isn't going to crash, right? But obviously the result we're getting really isn't right. We shouldn't be allowed, I shouldn't be allowed to enter these values. This is a true story, actually. A good friend of mine in high school, when we were in high school, her older sister had an average, a high school average in, well, back then it was grade 13, of 100%. She got 100% in every course. She applied to a whole bunch of universities, And one of the top universities, I think it was Yale, rejected her because their computer system only stored 2 digits for a high school average. So when they put in her average as 100, it said her average was 0, and she got a rejection. So she said, screw you, and went to Harvard instead. She works on Wall Street now, makes gobs of money. But their program could not account for a student getting 100%. Because she got a rejection letter and she called Yale and they said, your average was 0. And she said, you might want to look at my transcript again. And when they figured it out, they talked to their IT department, that was the problem. They didn't actually allow 100% in their system. And they rejected her. So what I want you to do with this now, so either with your own version of assignment 1, or if you don't have it with the version you downloaded, I want you to add input validation to check for these things, that each input is required and a valid number was entered. That number, what should the acceptable range be for the grades? What's the minimum and what's the maximum we should allow in this program? Probably 0 to 100. So then we should only be calculating this stuff if there are no errors. So if our first course is not a valid number, instead of displaying a letter grade here, we should put in a message saying, you know, enter grade between 0 and 100. And we should do this for all 6 of these inputs. Because right now it's just too easy to crash. So you can do it on your own. You can work together. You can ask for help. It's not a test. But I want you to try and add the validation that you need to the assignment 1, either your own or to mine. Okay. I'm going to stop recording right now because give you guys some time to work on this. I'm happy to come around and help you if you need help.